Hey, welcome to Formative Assessment 3.1. We're going to try to add these two vectors using just a calculator and smarts, right? So concept zero for these things is that I will never give you the trig angle. So if this is 42 degrees, for sure that's not the trig angle. So remember, that's 0 degrees, that's 90 degrees, this is 180 degrees. This is 270 degrees, right? And trig angles are always anti-clockwise from the x-axis, like that, okay? And so what that means is that as you go around this circle, right? If an angle is like that, it's actually on the minus side of 90, and if the angle is on this side, then it would be on the plus side, and here's the minus side of 180. And if it's something like this, which it's not, right? But if it were, it would be 180 plus whatever that is, right? This is the minus side of 270. Here's plus, right? So the first trick, right, is to figure out what that trig angle is here, right? So if this is 0 and that's 90, right, the trig angle is, it looks like that 42 degrees right there is the amount that we are short of 90. So the trig angle is 90 minus 42. Okay, so that's higher math. I have to do that with a calculator. No, I guess I don't. It's 48 degrees, right? That's our trig angle, right? Okay, so now let's figure this guy out here. This is 0 and this is 90. This is 180 over here and 270 just by the way, right? And so this angle here is, well, we're beyond 180, right? We're 180 plus whatever that is, right? Apparently it's 11.3, right? So the angle is 180 plus 11.3. My sources say that that's 191.3 degrees. Okay? Not quite 200 degrees, right? So that's our trig angle. Okay? And then once we've done that, the general rule is that any vector is magnitude, any vector is magnitude times the cos of the trig angle, right? And that's in the x direction, plus the magnitude times the sine of the trig angle in the y direction. But this works only if you have the trig angle. Okay, so let's just make sure we got the right trig angle. That looks right, 48 degrees. And yeah, okay. So now we're all set. We can just write this thing down. And I think what I'll do is because I'm such a spaz, is I'll make a nice table here. Oh, look how straight I can draw with this thing. I'm not just holding the shift key down to constrain the, right? So here's our, I'll call this vector 1. I'll call this vector 2. 1 and 2. Okay, and then we're going to do the magnitude and the trig angle. It's almost like we can make a spreadsheet, and then we're going to put our x component there and our y component there, like that. And ultimately what we want is we actually want to add these two together. We want to have 1 plus 2. Okay, so the magnitude of this one is 13.4, right? And the trig angle is 48 degrees, and this magnitude is 6.12. And the trig angle is actually 191.3 FM. I don't think that's a station. Okay, and then remember this side here, the x component, you get these with cos, you get these with sine. Okay, we're just using the unit circle for this, right? Only it's not the unit circle anymore. It's in this case the 13.4 meter circle. Okay, so here we go. 13.4 cos 48. 13.4 sine 48. Okay, now assuming that you are in degrees and not radians. Okay, I'm getting for my x component here, let's just double check. Okay, I'm getting 8.9664. Now we got 3 sig figs, I'm carrying 5, which is ridiculous, right? Okay, and this is meters in the x direction, right? So there's a part of the thing where we're supposed to write down what it is in components, right? So that's what I'm doing here. And then I guess we have to say plus. And then this is 9.9581. And that's meters in the y direction. And we're looking at this, right? And since that is a not an adorable angle, right? We expect it to have more y than x. And it should be, both of these should be positive numbers. And that's what I'm getting here, right? So there they are in components, right? Okay, let's just double check that. That looks good. Okay, so I've double checked it. The x should be shorter, the y should be longer. They both should be positive, so we're good. This guy I predict will have a negative x and a negative y, and a much smaller y, right? Just looking at it, right? Right, so this x will be negative, the y will also be negative. Let's just try it. So 6.12 cos, I'm just typing cos 191.3, 6.12 sine. Okay, here we go. So this is negative 6.001001. Gotta pick the right number. 4, I guess I'm rounding this to 4. Okay, and that's meters in the x direction. And this is negative 1.199. Then it's 19, so I guess 1992 is what I'll say. And that's meters in the y direction. Okay, it's customary to say plus a negative. So you've got, here's our x component, here's our y component, here's our x, here's our y. This is exactly what we thought it would be. It's a big x component that's negative and a smaller y component, and they're both negative. I'm just doubling, checkling. I can't talk. Okay, so now adding these is as simple as just adding them up, right? So I'm going to go 8.9664 plus a negative 6.0014. Okay, just double checking, and that is 2.9650. And that's meters in the x direction. Okay, and now we're going to do, let's double check that, 8.9664. I'm so bad at this, I mean, I just lack attention to detail. Okay, so here we go. 9.9581. Okay, plus a negative 1.1992. Is that what it is? 9581, 1.1992. I'm always, I just know I'm going to mess some up here. Okay, and I'm getting 8.7589. 8.7589, and that's meters in the y direction. Okay, now we've got the our job now is, and this is the last part, and you don't want to mess this up, right? Is we want to draw a picture of this guy. Okay, so notice it's not very much x, but kind of a lot of y, right? So let's draw a picture of that. That looks like this. Let's make that our x component, and then here's our y, considerably more of that, and then the vector is this thing here. Now don't forget to draw, you will not get full credit unless you make that thing an arrow. Okay, no triangles. Okay, and let's find that angle just for kicks. We got to find the magnitude, right? So this is 2.9650, and this is 8.7589. Okay, so my magnitude is the square root of those two squared, right? So 2.9650 squared plus 8.7589. Now be careful, if one of these components is negative on one of your assessments, don't put it in there as negative. It shouldn't matter, but TI calculators do unusual things with negative numbers when you square them, in my opinion. 2.965 squared plus 8.7589 8.7589. So what we got, that is, okay, here we go. All right, I'm excited about this. I'm about to get the magnitude. 9.247. So it's about 9.25. Right, and that would be what our magnitude here is, 9.25. Right, now we've got to find that angle. It's definitely going to be bigger than 45 degrees, right? So that angle there is the inverse tan of opposite, right? Here's the opposite side. Okay, so 8.7589 divided by 2.9650. Okay. Let's do that. Second tan, left parenthesis, 8.7589 divided by 2.9650. All right, expecting a number bigger than 45. It's 71.29. So 71.3 degrees. You got to have this picture, right? You got to 71.3 degrees. You got to label this side here. You got to find that magnitude. You got to find some angle like that. You have to label which angle you're doing. This has to be an arrow. If you do all that, you make your way through all of this without making any mistakes. Good for you. You've done something important. I'm not sure what it is. You've added two vectors. That's what you've done. I better stop talking.